All right, for example 12, we have a rational inequality. The same basic idea is happening here. We're looking for intervals where the signs are going to be the same. We want to figure out where signs can change in a rational function setting. What you'll notice about this one is it's less than or equal to 2. That's not any good. We want less than or equal to 0. All right? So job 1 is to get the 2 over the other side. So I'm going to get 3x plus 4 over x plus 1 minus 2 is less than or equal to 0. In order to be able to do that, I'm going to have to get a common denominator. I'm going to multiply top and bottom of this by x plus 1. Get that common denominator of x plus 1. Be very careful. This is a negative 2 here being distributed through, so it's negative 2 times x and negative 2 times 1. A lot of times that negative is forgotten on the second multiplication. So I have a denominator of x plus 1. 3x minus 2x makes 1x. 4 minus 2 is equal to plus 2. So priority 1 is get it less than or equal to 0. With rational equations, like a rational inequality like that, common denominator is required. Simplification of that to get just a single fraction structure is greater than or less than 0, in this case equal to 0. All right? Now, when you're looking at a division of something divided by something, anytime the top equals 0, the sign can change. Okay, because the fraction itself equals 0. So if x is negative 2, I get negative 2 over, or sorry, 0 over negative 1, which is 0, right? If the bottom equals 0, I get a vertical asymptote. So if I were graphing this, and we haven't actually learned how to graph this yet, but if I were graphing this, and don't graph it by the way. There's 1, there's 2. All right, oh, it's negative 1 though, negative 1, all right. So if I were graphing this, I would have a vertical asymptote at that point. And the graph itself is going to come up to it and either go straight up or straight down. Right? But sign can change. Maybe the graph goes like this. Once it crosses, it could jump down here. Or once it crosses, it could stay up there. I mean, I don't know, but the sign's allowed to change. It could be positive, it could switch to negative. All right? So that's just something to think about when you're dealing with a rational inequality. When can the sign change is the question. The answer is anytime the top or bottom equals 0. So in order to get my magical numbers for x to create my nice little intervals, I need to worry about if the top equals 0. That's just x plus 2 equals 0, so x equals negative 2. Or the bottom equals 0. That's going to be x plus 1 equals 0, so x equals negative 1. If the top were some quadratic function, let's say you had x squared plus 2x, or so let's say x squared plus 2x minus 15. X plus 5x minus 3, negative 5 and positive 3 both work. So, you know, you can get multiple answers. But in this case, they're just both linear. They both just have a single answer. All right? Now, I'm making intervals again. This time there's an equals to. I want you to be careful when you're making your intervals on a rational inequality. All right, watch how I do this. I'm going to go from negative infinity to negative 2 bracket. I'm going to go from negative 2 bracket to negative 1 parentheses. And I'm going to go from negative 1 in parentheses up to infinity parentheses. And the reason why, if the top equals 0, I get 0 over negative 1, which is 0, which is a number, right? If the bottom equals 0, I got 1 over 0, which is undefined. It doesn't exist. I can't actually put negative 1 into this problem. So I've got to put an open circle. Even though it says equals to, it can't equal anything at negative 1, so I've got to know that. So any bottom zeros, any bottom roots, get parentheses 100% of the time. Any top ones, you just have to look. If it's got an equals to, you put the bracket. If it doesn't, you put the parentheses. So the only time you really have to consider that is if there is the equals to. If it's just less than or greater than, it's all parentheses. But if it's equals to, there's brackets for top zeros, it's parentheses for bottom zeros. So again, I've got 3 intervals here. I simply have to test those intervals to see which ones make positive numbers, or sorry, negative numbers, because we're looking for less than or equal to 0, right? So for this interval, I'm going to pick negative 3. For this one, I'm going to pick negative 1.5. And for this one, I'm going to pick 0. Once again, looking at the structure, it's just something over something, so it's a fraction. So if I put negative 3 in, I'm going to get negative 1 on top and negative 2 on the bottom. Two negatives make a positive. For the second one, I'm going to negative 1.5 plus 2 is positive 0.5. Negative 1.5 plus 1 is negative 0.5. Divide, you get a negative. And finally for 0, 0 plus 2 is positive 2. 0 plus 1 is positive 1. Positive divided by positive is a positive. We're looking for less than or equal to 0, which is negative again, right?
Yep.
Which means this is the correct answer. And the correct graph, closed circle on negative 2, open circle on negative 1, shade in between. Okay. And just real quick, just I said it on the last one, I'm just going to write it on this one. If it had said greater than or equal to 0, okay, if it had that in the problem, then the answers would have been these two, right? So the way you would write that answer out would be negative infinity, comma, negative 2 bracket, union with negative 1, comma, infinity. And the graph itself would be closed circle here going this way, open circle here going this way. All right, just know that if you do get multiple answers, you want to put union symbols on them, like that. But again, this one was less than or equal, so oops. Hit the right button here. Make sure all my work looks like it's supposed to. Perfect, okay. So that's how they do the entire problem there. The only tricky part to these, again, is sometimes there's brackets, sometimes there's parentheses. Again, a root for the top gets you a bracket, a root for the bottom gets you a parentheses. And the bracket only exists if there's an equals to in the problem to begin with. If there isn't, don't even worry about that. All right? That's the one part that people sometimes mess up on. Quiz, I usually take a point or two off on a 10-point problem, so for that type of mistake. It's not a major mistake, but still a couple of points you don't want to get taken off. So